I'm just going to talk about thin lenses. You don't have to listen, but if you'd like to, you can. Okay, we're going to look here at just a quick overview of thin lenses and how they kind of work. We're going to concern ourselves with just thin lenses because if we go to thick lenses, we start have to caring about the thickness of the lens itself, and we start getting kind of into a prism problem from before, and we kind of don't want to do that. It's much easier if we deal with the thin lens, something similar to kind of like your glasses or your contact, and we don't have to worry about that thickness and light doing all sorts of weird things in it. For thin lenses though, we've basically got two kinds. We are going to look at a convex thin lens, which is often shaped like this. It bubbles out on both sides. And we also have a concave thin lens. You could imagine that the lens is actually going to bend inward like this. You can have other lenses. You can have like concave convex, concave plano, or plano concave, where one side is flat, a plane plano. You could do all sorts of kind of weird stuff with lenses, and you can change the focal lengths as well. But we're just going to talk about convex and concave, double convex, double concave, rather, because that's just the easiest to look at. It's what we traditionally look at in the world of physics when we're just doing introductory stuff. If we look at a double convex, though, and I'm going to kind of draw this a little larger, technically speaking, when the light is coming in to the lens, it is refracting in it. It's hitting this medium, and it's causing the light to slow down and bend. And if we kind of look at this, normal to this surface right here is that line. So as this light comes through, it's going to bend closer to that line by some amount. This is Snell's Law. We've already seen this a lot. What we can say with this, though, and this kind of gets a little bit weirder, like I said, for a thicker lens, because we actually go in here, we bend a little bit, and then we bend a little bit more coming out. But we're going to pretend, for all intensive purposes, that the lens are like thin enough that it hits it and we just get one straight bend. Okay, we're not going to worry about the whole, oh, you're bending twice nonsense. It's not nonsense, it's tedious. So what we can do is, in order to ignore this kind of double bend, instead of drawing a double concave like this, we are just going to draw a double concave as a straight line. Easiest way to draw it. And this is our thin lens. Basically what happens here is, from a point very, very far away, as all of the incident light comes in and strikes our lens, that lens bends all the light to, can you guess the word I'm looking for? One point. Begins with an F. It bends the light to the focus. Okay, so we get the light to come down through the focus, through the focus. Light coming center just goes through the focus, through the focus, through the focus. Okay, so that's the idea with a double convex lens bending light. Bends light to the focus. If you take a magnifying glass out to the sun, you kind of move it back and forth a little bit, you can get that perfect focus when you get that point of light to be that perfect tiny little dot. It's what you would use to kind of like burn ants or something like that if you're a diabolical fiend of the intergalactic. But that's the idea with a convex lens. You're bending the light to a focus. With a concave lens, easiest way to draw this with a line, and then that's our double concave. Just much faster to draw that way. There's our principal axis. And for the double concave lens, what's actually happening is, as the light enters it, we can kind of see this if I draw a small little picture here. Because this surface is curved, as this light is about to hit it, and our normal is here like that, the light's going to bend towards the normal once again. So the light actually bends that way. And light striking the bottom does just the opposite, because this is the normal line here. It bends this way. So all the light is going to diverge. So what ends up happening here when we look at this is our light's going to diverge. Light at the very tip would kind of go like that. Light passing through the center just keeps going straight, but the light down here diverges down, and if we go even further at the edge, we'll do that. So our light diverges out. What we can actually do is if we backtracked all this light, we would arrive at some focal point. Now the interesting thing for these lenses is, unlike the mirrors where the light hits it one direction and bounces away, these focal points actually exist on both sides of the mirror, because assuming these mirrors are double concave or double concave or double convex, you can shine the light either way through them. It doesn't matter. So we actually have two focal points depending on how you're looking through that mirror. Okay. So that's kind of the idea there with these two lenses. Now, kind of the more difficult thing to do with some of these is to kind of play around and create the lens maker equation, or not the lens maker equation, excuse me, just the lens equation. It's going to look very similar to what we've already done with mirrors. It's going to have the same form, as we'll see how to create this in class, of 1 over d or s naught plus 1 over di or si for the image equals 1 over f. It's going to be the same equation. We've already used this equation. Nothing new is happening there. Okay, it's just a matter of us once again recognizing when do we have negatives, when do we have positives, and kind of how this stuff can get set up. Okay, we'll see a lot more of this in class. The only thing I'd like to highlight just kind of right now is if you do have a strange scenario where you have two lenses back to back, like you have a double convex here and then a double convex here, and the light is bending through, and then it's like striking the other lens or something of that nature. Treat it as just one lens twice. Okay, so we'll see how to make these images in class, but treat it going through one lens, make your image, and then take that image and treat it going through the other lens to make your image again. Okay, so it's just one lens problems, but you're doing it twice. We'll see kind of some of that whenever you start playing around with the telescopes, whenever you start designing those. Okay, but just some basic stuff as we start getting into thin lenses, some stuff to keep in mind. Okay. Some people just jumped in.